panel B, we've got the probability values for all of those set to 0.05, with a different data set here. And we've got, overlapping standard deviation bars that overlap by quite a bit, but that's still a significant difference in this case. And then we've got standard error of the mean bars, which have no overlap whatsoever. And we have a probability value of 0.05, right? About a 5% chance of getting data like that at random. And then with the 95% confidence intervals, there is overlap and we still have a 0.05 chance. And this kind of brings me to kind of, I think a lot of the rules that people have about if error bars are not overlapping, then you have a statistically significant result, sort of lead us down, or they make it very easy for students to make mistakes. And so if I'm sort of kind of pointing this out, I would say if 95% confidence intervals are non-overlapping, then there is a statistical difference at the 0.05 level. But the reverse is not necessarily true, right? And we see that in panel B of that figure. You can have overlapping confidence interval bars and still get a statistically significant result. And the same would go for 2SEM, right? Because they're very similar to 95% confidence interval at large sample size. So as a kind of take home for this, I would sort of implore you to think about that. Error bars are really much better for visualizing data than they are for testing a hypothesis, for telling you whether you should accept or reject a null. I think that overall, they are much, much better at visualizing your data. And you always need to think about what kind of error bars you're looking at. And so like if